who was here and who wasn't. So what we're gonna cover here. So the control system, to put it as basically as I can get it, is the brain of the system of your offshore well. It's telling all the equipment that's subsea how to operate. Okay, so it is the key piece of equipment that is operating the field. So you're going to put this equipment on that host facility, whether it be in a shallow water, a platform. You saw all the different kind of production units that are out there, the spars, the TLPs, the FPSOs. So just think that all this equipment that's subsea is going to be controlled by a surface, some type of floating host out there, and that's where this equipment is going to be installed, and that's going to be the brain that tells this tree and tells all those downhole functions what to do. So we're going to talk about functionality, the different types that there are, the umbilical consideration. The umbilical is the conduit that's going from the host facility to the well, and how it ties into the safety that's already on place. A lot of times in the host facilities, there is already wells that are producing back to it. It's not always just a brand new well that's specially built just for your well. A lot of times these hosts are already in the field, and what you're doing is adding to an existing system. So with that said, then it has to tie into the safety system that's already aboard. And then accessories, chemical injection, we talked about that in the Christmas tree section, and we also talked about the iWalk system. The iWalks is a control system, so it fits into this part of the seminar once again. iWalks is going to come up many times in the seminar because it is a piece of equipment that if you unplug that umbilical from the tree or from whatever it is controlling, if you pull it away, just much like a vacuum cleaner out of the wall socket, it has no more power. So what the iWalks is doing is supplying the power if the umbilical is unplugged from the well. So it generally is put up on a vessel, maybe a boat. It may be installed on the host facility, but it's the temporary control system that's controlling the well when the umbilical is unplugged. Just think of it that way. Sometimes when you go out there and you start up a well, maybe the umbilical is not hooked up yet. So this is the temporary control system. So it really is a part of the control systems. So first one is the different styles of control systems. Remember in the tree section we talked about the offset distance and how fast those valves have to close and open. 45 seconds for 3 of the valves on the Christmas tree have to close in 45 seconds. If the offset distance gets longer, that makes a difference on what kind of control system you have to purchase. Okay, just keep that in mind. Those valves, 3 of the main valves on the tree have to close within 45 seconds. If a direct hydraulic system is used, meaning that, and I'll get into the different ones, but if it gets so long that that valve cannot close in the 45 seconds, you may have to go into maybe it's step number 2 and maybe even to step number 3. So just think of, there's 3 main systems that you have to have, and that's based on how far away you are from that well. The well control panel on the HPU. So generally the HPU consists of a well control panel, which has all of the functionality, much like the HPUs that you guys work on in the shop. Generally, they will have a schematic that mimics the Christmas tree or the downhole functions. So when the man or woman walk up to it, they're very clear on what they're fixing to do if they do decide to move a valve into a direction. So you'll walk up to this, there will be all the functionality for for controlling those valves and functions, as well as some kind of master plan on what you're doing so you don't make a mistake. When you get into VOP control panels, as Jim can attest, the thing is about maybe 3 or 4 times as complicated as a single well. So when you walk up to that thing, it has all kinds of components that have to be opened and closed. But a single well will consist of the well control panel. Generally, stored accumulators will be installed on it for stored power, so that whenever you do throw that valve, you're not just waiting for the pump to kick on to make that hydraulic fluid move. And then it'll generally have in the backside of it some type of reservoir that has the hydraulic fluid in it that will, remember I made mention that the valves on the Christmas trees are fail-safe what? Good listening. Closed. They're closed. You want, if you lose this hydraulic power on a Christmas tree, for whatever reason, whether the umbilical gets cut, maybe a fitting gets loose, you want that valve to close. If you lost that function and you have no way of opening and closing that valve, you want the well to shut in. So you want it to be fail-safe closed. If that direct hydraulic fluid that's keeping that valve open, if you lose power, you want that valve to close. Okay? So then we're going to get into some of the more sophisticated systems as well. Questions? So let's concentrate on 3 of the different types. So direct hydraulic control. So this to the left over here is basically that HPU that you just saw. It's sitting on the host facility. You see the accumulator, you see the valving system, and generally the hydraulic reservoir that's holding the fluids. So basically what you're doing is if you want to open that valve on that Christmas tree or downhole function, you push the hydraulic fluid towards that valve and you push that valve open. Once you've got that valve in the open position, then you have the ability on the panel to lock that fluid in so that it's constantly holding that valve open if you want that valve to be in the open position. So this is good generally if you use a thermoplastic hosed umbilical, which if you guys in the shop know that when you pressure up a hydraulic hose, when you initially hit the pressure and you see your, let's say it's 5,000 psi, after a period of time it will back off that 5,000, it'll bleed down, and you may have to kick it back up a couple of times back and forth before you finally hold that 5,000 psi. You know why that is? That hose is expanding and retracting. It's growing. It has the ability to stretch out to a certain point. So sometimes when you're hitting that hydraulic fluid in there, it takes it a while for it to completely expand that hose to its extreme, and it can't go anymore. So when you talk hydraulic, direct hydraulic with a thermoplastic hose, you may have to keep that thing functioning a couple times till you get to the PSI you want and then lock it in. If you have any kind of leaks in the system, you'll see a small bleed off, and if you have the HPU hydraulic power unit that you're watching it, you may have to keep hitting the pressure on it to keep that 5,000 psi to keep that valve open. If you're slowly starting to see that bleed off, you know you've got some kind of leak somewhere. So if you have a steel tube umbilical, steel tubes don't move. So once you hit that hydraulic power and it gets up against that valve, it should remain at that 5,000 psi unless you have some kind of leak. So generally in the direct control system, the rule of thumb is somewhere about 4 to 5 miles long. So from here to Willie's at Jones Road, is that about 5 miles? Maybe WW, I'm not sure what the distance is. 3 miles to WW, whatever it is. So you'd be comfortable with a thermoplastic hose umbilical being able to close those valves in 45 seconds. So when you say close the valve, what does that really mean? It means when you do close that valve, what's happening is that hydraulic fluid that you had in that line has to return back to the HPU into that reservoir. So that's a bleeding process. That hydraulic fluid actually travels back into the reservoir. And then once you want to open that valve up, you pump that fluid back, it travels through the umbilical and opens that valve up. So when you're, say, closing a valve, what you're doing is you're making that hydraulic fluid travel back into the reservoir. You get past 4 or 5 miles, now you may have to do something different. You may have to trick the system, if you will. Not really trick it, but you've got to do, and you've got to spend a little more money. You remember in the Christmas tree section I showed you the pods, or the SCMs, the component that is put on the tree that receives electrics and hydraulics. We talked about it was a separate component that was added to the Christmas tree. So that's what we're talking about. This is representing that subsea control module, or the pod that we made mention of in the Christmas tree. So what it's doing is it has a series of valves built into that, shuttle valves that are built in there. And with electrics and hydraulics, you're operating the valves at the tree, not back at the host facility. So this is a system that has to have, with that hydraulic power unit, hydraulic HPU and an electric system that allows the two to work in conjunction with each other. So you send an electric signal to the valve, and then with the hydraulic fluid already at the valves or at the Christmas tree, the operation moves much quicker. You've got the hydraulic power stored at the Christmas tree. Y'all understand that?
Swap it to the one that you were just pointing in as a hand pilot.
Oh, okay. Well, I'm not sure what I'm pointing to when I'm pointing.
Oh, okay. No,
I'm just-
I wouldn't say electrical.
Okay. But do you see that what we're doing here? So instead of that hydraulic power having to move all the way back, it's being stored at the Christmas tree, and so you don't need that volume. So you're working with electrics and hydraulics at the tree. Thus, the response of closing that valve is much quicker. Then if you get into deeper water, longer offsets, you may have to go to a multiflex electro-hydraulic system, which is basically somewhat of the same, but a lot more complicated in the electronics and in the power. Okay, so short wells, short distances, medium distances, and then deeper water, longer offsets. In the introduction, I told you that there was one well, a couple of wells that are in Norway. One of them was 89 miles, and I think the other one was not too much. One was oil, one was gas. 89 miles. So what do you think, what kind of hydraulic system do you think they're using?
Multiplex.
Yeah. So it's all about how far away you are and how those valves open and close. Ultimately, it's always the Christmas tree valves or the downhole valves that you're trying to open and close. Just depends on what the offset distance, water depth. It's all about that. Once again, every component that we talk about in the seminar, water depth, offset distance. Just keep that in mind. Okay, did I go too far? Was that it? So here's the direct hydraulic system. So here's that reservoir that I made mention of with the hydraulic fluid. Some kind of level indicator that's included in it. I made mention if you start losing the hydraulic power, starts bleeding off, you'll tie it into some kind of level switch, will be an indicator, maybe an alarm or something on the host facility that will sound, so that you know you may have to walk up to that panel and give it a little more juice. So what you're doing now is you're marrying in your hydraulic power system, and you're trying to marry it into a system that's already existing on the host facility, whether it be the FPSO, a platform, or whatever. So with that said, there is also a well logic system that's tied into this. So all of these components were part of that HPU that we looked at earlier. Some kind of pump to push the volume, some kind of pressure switch, the stored accumulation, pressure regulator, and then tying into some kind of logic. So let's talk about the logic. So on all host facilities, they have a master plan for well shutdown. So depending on what activity is going on, there are alarms that are set in place to alert the people of what kind of function it is that may be causing a problem. So when you're bringing this new equipment onto this host facility, you have to tie that system into probably a pre-existing system, okay? That's what I'm talking about, well shutdown. And it comes in different levels. If you hear, let's say you're sleeping in your bunk and you hear an alarm go off because they've got a fire in the galley. Maybe they've got the grease too hot in the frying pan, which is a reason to alarm, but it's not a big enough reason to maybe shut down the whole well. So there's different levels of what this well shutdown means. If you have a catastrophic fire going on the host facility, yeah, you probably want to go up to the panel and shut the well in. The last thing you want is for oil and gas to keep coming to the host while you're dealing with a fire on it. So there's different levels of what you do as far as alarms go. But when you're bringing this equipment onto an existing facility, you have to marry it into that system. Okay, does that make sense to you? So a little bit more about the hydraulics, the HPU. So this gives you a little bit better picture of what I first showed you. So you've got, once again, this particular hydraulic power unit doesn't mimic the Christmas tree, but it also incorporates all of your electric and power systems. So these things get from being very small, maybe the size of a phone booth for a direct hydraulic, to gigantic if it has a lot of equipment that's brought into it, okay? There's the accumulator bottles that we made mention, and here's the backside with some kind of reservoir that's holding all that hydraulic fluid. So that's pretty typical of a hydraulic power unit. The actual components that are opening and closing the valves, the stored accumulator, the pumps that's pumping this to the well, as well as the fluid containment. So this is a pretty good example of the series of events and the type of equipment that this stuff has to go through. So you're up on your host facility, and you see that same picture. It's going to have to be plumbed to some kind of topside umbilical termination, meaning that all of the functions, and generally all of the functions that it takes to control the wells, are independent. Some are shared. We'll get into a little bit more of that. But envision if this was a 10-function well, there will be 10 lines that have to be plumbed somewhere on the host facility and terminate somewhere to where the umbilical is brought up to the host facility. And that's generally terminated with what's called a TUDA, a topside termination. So you're marrying the hydraulic functions into where the umbilical comes aboard your host facility. Then the umbilical will be run from there all the way subsea and will terminate to some kind of an umbilical termination assembly, which is called a UTA, some cases an SDU, a subsea distribution unit, or an umbilical termination assembly. So here's the routing. So now from here now, you will take a hydraulic flying lead and plug it into the UTA and fly it over and plug it into the Christmas tree. Now you have a complete circuit all the way to the well. Everybody sees that? So with each one of those components means interfaces. So at every time you have an interface, you have a possible leak path or some kind of something that could happen to you. Some of the shallower wells on mudline systems bypass this, and some of the wells are just plugged with the umbilical directly into the Christmas tree. But generally in the deeper waters, you always have some kind of umbilical termination. So a little bit more of the electric, hydraulic, and the multiplex systems. Now we're talking about additional equipment. So what we've been talking about so far is hydraulics, how we're moving that hydraulic fluid back and forth. Well, when you start introducing electrics into the system, now you're talking about a more complicated umbilical, because now it has to have copper, or maybe in the new world is fiber optic. So the fiber optic on a Christmas tree and downhole is being used to monitor pressure and temperature. So it's a much quicker way and a better accurate reading back to the host facility. We talked about the pressure and temperature sensors that we put on the Christmas trees. So that is what is being plugged in and traveling back through the fiber optic back to the host facility. And at the host facility now, our equipment is getting more broader, bigger, complex, because now we have to monitor the hydraulic fluids, the electrics, and fiber optics. So now you're talking about more real estate. So here's a subsea module. So sometimes they will build separate rooms on the host facilities. Once again, for fires and things like that. If something else happens on the rig, you want to make sure that the operating system is safe. So now we're talking about not just setting a hydraulic power unit on the deck. It's a hydraulic power unit, some kind of electric system, as well as a power source. Generally, when you put your equipment on the host facility, there's two ways to drive an HPU, whether it be electric or pneumatic, that's making those pumps work. So you may have to start introducing more equipment, and believe it or not, real estate on a host facility gets to be a very serious issue, not only from the size of it, but also from weight. So you have to start, when you start talking about that electro-hydraulic or the multiplex systems, more elaborate. So you have to have electrics now. The electrics that are being introduced into those shuttle valves in the control module. So not only are you hydraulically running, but you're also sending electrics down that umbilical to function the valves. So as you can see, more real estate, more equipment. So you just saw the electric power and you saw the computer system, some kind of modem down through the umbilical to the Christmas tree, into that pod or subsea control module, into some type of a shuttle valve, and then to the tree. So you've got hydraulic power going to the valve. You also have electrics and fiber optics going in. And inside that pod that we saw on the Christmas trees is where all of the magic happens. That's where all of the brain now is stored on the Christmas tree. And by sending a signal on the host facility on what you want to do, because of the long offset distances, is done in that pod. And then the pod does the work of opening and closing the valves. Generally, when you the hydraulic power, if you decide to close that valve, what happens with these systems is they all vent on the electro-piloted and the multiplex systems. They will spit out a small amount of that hydraulic fluid. Remember the fluid that it takes to open and close the valve, and as Meg mentioned, it has to travel all the way back in a direct hydraulic. On this, it's about maybe a teacup full of hydraulic fluid that is spit out into the ocean. But don't worry, for all you tree huggers out there, it's okay. It is environmental friendly hydraulic fluid, so we're not killing fish or anything, and it's a very small amount. Okay, so instead of that fluid going somewhere, it's generally just pushing out into the ocean to get rid of that hydraulic fluid instead of having to send it all the way back. Does that make sense to you? So inside of that pod now, here are the shuttle valves that inside that pod is some of the most complicated arrangements that you could ever imagine, especially if it's multi-function, multi-electrics. Some of these things, and the reason for that then is just like everybody else, they want a smallest package, less weight as you can put on the Christmas tree. So when you start getting into these control pods and subsea control modules, they are very complicated pieces of equipment because they are full of these shuttle valves and they're full of electronics and everything. So generally, if you remember, probably not, but if you saw on the Christmas trees, when you saw one of those control pods, at the very top of it, it had a mandrel that stuck up. So why is that? What's going on there? If this pod with all of these multi-functions goes bad, you can run a boat out there, lower a running tool, and you can actually pull this subsea pod from the tree without having to pull the tree. So these pods are retrievable. Generally what the oil companies do will buy a two set, one to control it and one to keep it open.
Thank you.
You're welcome, sir. I had to use you for an example. Okay, where was I? Let's see. I kicked Jim and then what happened? Okay, we're retrieving the pods.
Yeah, the pods.
Retrievable. So that makes sense to you, right? So they're retrievable. Remember the chokes that we put on the Christmas trees? Remember we dialed in the chokes for different orifice sizes? So what happens is this equipment, especially these shuttle valves, some of those things can be like 1/8, 1/16 inch lines inside of them. So one of the things that's the most important to a control system is the hydraulic fluid. That hydraulic fluid is continuously run through a set of screenings and cleaning because the last thing you want to do is have the hydraulic fluid come in here and plug up one of these valves. And it happens a lot of times. This equipment will start deteriorating and scaling, and if anybody's ever worked with hydraulic fluid, you know that to keep that fluid clean is very, very important to you. The reason being is you've got very small, complicated pieces of equipment that will clog up and you lose your functionality. If you lose your functionality to that valve and that tree valve will not open and close because of debris got in here, you may have to run out there and pull that pod. And generally, like I said, you have a spare that's identical to the one that's in the well. They'll run out there, pull one, put the new one on, you're back in business, go back to the beach, and you'll send it back to the original manufacturer and he'll clean it up for you and get it functioning again as a backup. So it happens all the time. So one of the things that you got to keep in mind, you being the people who are buying this equipment, you now know that what tree you bought. Now you got to figure out what kind of control system you're going to buy. And not only, you're not just the guy and the girl who is buying this equipment for one well to start it up. We're talking about the life of this well. What's going to happen to it in a 5 to 10 year life expectancy of this well? What are the problems you're going to have? So here's some of the thinking that goes on in the world. I was in Mexico doing this seminar, and we had the head guy of Pemex. And so I was explaining this to him, and he was back there shaking his head. And I was going, well, what's the matter? He says, what do you mean going back and servicing the wells? And I said, well, this equipment is complicated. It's going to happen. Things are going to break. Things are going to happen to it over a period of time. And I said, what is your plan for servicing those wells? Are you gonna have a dedicated vessel? If you've got 10 or 15 wells, that's 10 or 15 different problems on a given day, if something's gonna happen to one of those wells. He said, no, we're not planning it. What about your spare philosophy? What are you gonna do about spares? He said, we're not gonna have any spares either. And I was waiting for him to start laughing at, it was a joke. He was serious. His mindset was, when I buy this equipment, it's gonna work for 10 or 15 years, and I'm never gonna have to go back to it and work on it.
Why? Because it's expensive? Was that his mentality perhaps?
His mentality was he had never done it before, and he doesn't know all the things that happen over the lifespan of a well. He hasn't had that life experience to him yet. Keep it in mind that things are going to go wrong. Even though you bought from the original manufacturer and they had a warranty, doesn't mean anything. It's going to go wrong. Generally, the tree manufacturers or anybody that's selling this equipment, their warranty is getting it to the field, and when that well starts up, their only warranty is that if something goes detrimentally wrong with it, the operator is responsible for bringing that equipment back to the surface, getting it back to the original manufacturer, and getting it serviced back to the docks, back to offshore, and back installed. That's their warranty. Okay? They're not gonna, sometimes you can pull the equipment and you can work on it and send it back down, but generally it's got to go back to the original manufacturers. Okay? So they're kind of stuck on that. And so make sure that you have a good spare philosophy and have things in stock that you're able to bring out of here, get it to the docks, and get their operation back in service again. The umbilical itself. Next week we're gonna have a section on umbilicals. I was lucky enough to walk away from my last job that I have quite a few samples that we'll be able to look at to show you the cross section of what this functionality really is. So this is a hybrid type of umbilical. You can see these kind of non-oval hoses. You see steel tubes, and you see the electrics. So this umbilical is controlling valves with hoses. Generally, when you see a hose arrangement with steel tubes in it, generally that's your chemical injection lines. That's the chemicals that you're sending to the tree. And then once again, the electrics for pressure and temperature are possibly operating those valves, the shuttle valves in the pods. That's a pretty good example there. So I'll have some examples that you can look at and see the differences. Shallow water, all thermoplastic hoses with a short offset distance, cheap. Some of the umbilicals are all steel tubes. They can't afford to put thermoplastic hoses in there. So I'll show you an example of a umbilical that's all steel tube with electrics introduced into it and fiber optic. So what are you trying to do? You're hydraulically opening and closing valves depending on your offset distance, and then the chemicals that are being introduced either at the Christmas tree or downhole are generally run through a steel tube line. Why do you think that is? Why would you put steel tubes for your chemical injection lines? When this oil is flowing, remember, it's not your 30 weight, 40 weight oil that you're pouring in your car. It's nasty, nasty oil. It's got waxes, asphaltenes, all kinds of nasty oil derivatives that are in that stuff that is causing it that it doesn't want to flow on its own. That's why you may have to inject chemicals to help break that oil down so that it will flow. So with that said, if you think that that oil is nasty, and full of all kinds of things in it. Think what kind of chemicals you may have to pump into the well to try to break that up. They're even nastier, okay? So probably not a good idea to send a corrosive fluid down a thermoplastic hose. What would happen? Generally probably eat it up, huh? It destroy it. Well, steel tubes isn't going to know it's a steel tube unless the corrosion chemical injection that's being put in the well, you also have to keep in mind what it is that you're going to pump, because even some of the steel tubes won't take that volatile of a chemical. So there's a lot of different varieties of steel tubes that you can buy depending on what it is that you're going to send down that tube. So keep that in mind as well. And then of course the electrics. So a couple of charts, and this is going to kind of tell the tale of pressure versus time and what happens. The valves themselves that are in the Christmas trees, fail-safe close. So what that means is when you're pushing that valve open, you're pushing a spring from the backside of that valve. You're pushing that spring to overcome and open that valve up. When you lose that hydraulic power, the spring is what's actually closing the valve, not the loss of the hydraulic fluid. It's the spring is pushing that gate closed and closing the valve. Okay, so what you're really overcoming on a tree valve is not the hydraulic fluid moving, it's that spring. So that spring will activate when it gets to a certain loss point. So there'll be a time when, as you're closing that valve, nothing's really happening. The hydraulic fluid's moving until it overcomes, till it can't take it anymore. The spring activates and then closes the valve. So what this chart is telling you is how long it will take to do that, what position the valve will close in, and what kind of pressure it will take. So when you go to these, the Aukers or the Oceaneering or the Parkers or whoever manufactures umbilicals, there's a lot of information that has to be swapped back and forth on what you're trying to do and how you're trying to do it. All of these companies have computerized systems that will work with you and get you the right kind of close time, what it's all doing. So the five Christmas tree manufacturers that we've already identified, every one of their valves works differently. They have different criteria to each valve because they generally are manufactured differently by the 5 different manufacturers. They all have differences in what these response times and how those valves close. So you have to know what Christmas tree you're buying, what kind of valve, and then through back and forth communication, you start working out through computerized systems what the best fit your hydraulic power unit needs to be. So that's one, that's closing. And this one was showing you if you use hose, so the size of the tube matters. Because if you can't get things to operate the way you want them to with a size, then you may have to open up and go to a different diameter to make these close times and open times happen. So it may be that instead of using 1/4-inch hoses to get your response time, you may have to go bigger to a larger hose to make that happen. So it's not only in the closing times, it's also in the size of the diameter of the component. So why would that matter? The difference, if you were 39 miles away and you had 1/4-inch hose, how much does it cost? Let's say it costs $25 a foot. If you put 3/8 in there, maybe it's double that. And 1/2 inch maybe double even that. So over 39 miles at so much a foot, your umbilical price starts growing. So you'd like to go 1/4 because of the cost savings in the umbilical. But if you can't get the response times that you need, you may have to up the size. So this is once again that exchange is going back and forth between the tree manufacturers, the operator, and the wellhead manufacturers, and whoever's putting all this together. So there's a lot of work. I don't know who it was wasn't Chad. It was Scott was asking how long all this takes to do. All this information goes on and on and on, back and forth. Picking a vendor, picking the control system, picking the umbilical. So, once again, steel tubes make a big difference. Same equation, but maybe the size has to change to get the kind of response time that you need to close those valves. So, hose safety, we kind of already ran through this with you, so I won't elaborate too much on it. But once again, the fire in the galley doesn't necessarily mean you shut the well in. So there is a sequence of events for shutting this well in. The problem with shutting a well in is that every time you shut a well in, when I say shut a well in, I mean closing it down from producing the oil and gas, means that you may have the risk of that well may not start up again. It may not come back to life again. So you're real leery of completely killing the Christmas tree and stopping that flow. So that's why the safety system is important, because if there are different activities that are going on, you may not want to completely close the Christmas tree. So all that has to be married into the logic that's going on in this host facility. There's multiple valves they're called inboard valves. So if your gas and oil is coming up to this host facility, there's a whole series of valves in there. And the last valve that comes up onto the host facility is a very important valve, because that is your last piece of stoppage of that oil and gas. So it's a very key. So it generally is if you are just about ready to start heading for the lifeboats, there's generally a red button that says do not push. Push that button and that valve will stop, and you now stop the flow of oil and gas up to that host facility. But from the Christmas tree all the way to that valve and past that valve are a whole series of valves depending on what you're trying to do with this oil and gas. Okay? And all that has to tie into the host safety plan. Where do you want, at what point do you want this oil and gas to stop? So this is what you do. From the very start of your buying this equipment, you start building a plan of what you're wanting your Christmas tree to do and how it's going to marry into that host facility. So at the top here are all the different functions on the Christmas tree. So whether it be downhole or at the tree, you identify what each one of these is and how you want it to react. Okay? So you build a plan. You got to know, you got to think of this overall system of what you're trying to do. And then you put in the equation of what do I want this equipment to, what do I want to happen? If there is a leak in the hydraulic power unit, and I made mention of an alarm going off that you need to walk up to that panel and maybe give it a little more juice, that's an event. So somewhere there has to be an alarm that goes off. You don't want to just allow someone to walk up there daily and check it. You want an alarm to go off, because you don't want that tree to close if you don't have to. So functionality and what you want it to do, and that's where the reservoir load comes in. So what do I want? I want a platform alarm to sound when my reservoir fluid is low. If it gets beyond, you want a secondary alarm. You want something else to happen. Maybe it's a single blast. Maybe it's a blast. Everybody has to learn this level and what these alarms are. The last thing you want to go do is hit that red button because you have a low level in your hydraulic fluid. So you kind of catching on with what I'm talking about with the alarm system on this equipment? Very, very important, and very, very important from early on that you start planning for all this stuff, knowing what everything does, every function. Everything has a reaction to something else. So if you do one thing, you may be creating something else. And if that's the case, how do you get past that? So you have to think through this whole logic. So it's very complicated. So the control systems. So we saw a picture of the TUDA, a topside termination assembly, control modules in the landing base. Those are what go on the Christmas tree. Tree intervention panels. Mr. Colley, he can tell you all about these guys right here. Programmable bridging plates, I'll speak shortly about those. And then the sensors themselves. So accessories. Don't necessarily have to have all these. Some cases you do. You start getting into the more complicated systems that have steel tubes, thermoplastic, electrics, fiber optic. Now, not only are you dealing with hoses and steel tubes, you're dealing with all those electrics. And you saw that cross section of that umbilical? That's where it comes up. So you've got to split all that out at the top side. So by saying that, now your topside termination is getting a lot more complicated. You're trying to isolate where the umbilical comes aboard before it goes to the equipment. So the pod, the SCM, the one that I keep making mention of. So if you're going to put an electro-piloted or a multi-flux system, it's going to have a place on the Christmas tree. We saw that in the Christmas tree section last week. So when you buy a control module from Aker or Oceaneering or whoever you buy from, Oceaneering really doesn't get in this business. More of an Aker, there's specialized companies that build these, but you have to have a base that gets incorporated into the Christmas tree, and from there it is plumbed to all the functions on the tree, and then you're going to set the subsea control module or the pod into that receptacle, and through the hydraulic couplers and through the on the top side, see these guys right here? That is where your electrics come into play. So from your umbilical termination, your UTA, you split that out, and you will have hydraulic flying leads, and you will have electric flying leads, and in some cases you'll have fiber optic flying leads. You separate all that out in the umbilical termination assembly, and they're run independently to the Christmas tree. You don't want to put all your functions in a flying lead, because if you have a hydraulic problem, you don't want to unplug the flying lead and deal with it and maybe damage the electrics and the fiber optics while you're working on it. So what's common practice is each function will have its own flying lead. Hydraulic flying leads, electric flying leads, and
Fiber optic.
yeah, are listening. So hydraulics come in and run to these couplers, by the way, are generally the same couplers that are used in the umbilical when it's plugged into the Christmas tree. When you plug that flying lead into the Christmas tree to get that hydraulic fluid moving, they are generally, Hunting has the biggest numbers on these couplers. So not only are they used in a pod, but they're also used in the junction plates that plug the umbilical into the tree or the flying lead into the tree. Same thing, they're basically a check valve. So they're spring loaded as well. So they're meant to keep the hydraulic fluid from coming out when they're not in operation. The way they work is that when you bring the two together, they both have pins on each end, and when you make them up, the two pins hit each other and they push each other off of their seats, and that's how the hydraulic fluid goes around it. So Hunting is the big supplier of these guys. They work on both the pods and umbilical junction plates. Made mention of the top side for pulling these guys. So you can see this is an independent piece of equipment that plugs into the Christmas tree, and once you plug it in and connect it up, now it's doing its functionality. And if anytime you have a problem, come out with a boat, and he will have a running tool that will grab a hold of that top section up there, and you're able to pull this whole pod back to the surface without disturbing the Christmas tree. Pretty good shot of one right here. See the couplers right here? Those are the couplers that we're seeing right there. And we're showing some kind of a shroud that the pod sits down in. The hydraulic functions come in from the junction plate on the Christmas tree. The electrics, we'll see that again. They plug into a receptacle on the Christmas tree, and then they jump up to the top of the pod and they're plugged in, and now you have your electrical extension cord, if you will, plugged in. Tree intervention panels. So on all trees, you're basically gonna see, and this is not just true about trees, but UTAs, manifolds, anything that requires intervention to it, meaning an ROV that can fly up to it and make things happen. So in this case, we're talking about flying leads. We're talking about ROV operable valves. So we have our flying lead connection. That is where the flying lead will plug into the Christmas tree. You'll see a better detail of it. You probably saw it in the tree section. That's populated by all those hunting couplers. Same type of coupler. So that's where you're going to plug your flying lead into to get your hydraulic source. Generally, they will put a parking so that if you had to pull this, you can park it over here instead of just dropping that flying lead in the mud. So you plug it in here, and now you've lost power to the tree hydraulically when you disconnected it from the flying lead connection. So it's a good idea to put yourself a parking receptacle on there so the ROV can unplug it, swim over a little bit, plug back in, and now he's not dropping all that stuff in the mud. So operable valves, meaning these guys up here, so they do not have an independent hydraulic function that's plumbed to a function on the tree. If you want, in this case, chemicals, just say this guy right here, he's in the open position. That means that one function is going to that valve, and if you want that function to be in the open position, those chemicals are going where they're supposed to go. The backside of this panel can be plumbed as such that if the ROV flies over and closes that function, he's rerouting to another function that didn't have hydraulic fluids going to it. He's opened that channel. And so a lot of times you'll put two-way valves on here that will allow you to function one way. If you don't want to do it anymore, swim an ROV out there, and now he's opened the hydraulics to a different component. So you'll see a lot of these guys on Christmas trees and manifolds and templates. And this is what do you call that, Jim? Tell me what you call that.
Subsurface safety valve. That includes the bottom valve and the very bottom of the well. And that's a backup with hot stab driven.
So it's already got a hydraulic function. But what happens if somewhere from the Christmas tree downhole something goes wrong? He could swim out with an ROV. He could pull that out of its receptacle and come in with his ROV hot staff and pump down into there and close that valve. So you'll see a lot of hot stab functions on these panels that are just sitting there. They're plumbed to the tree or to the manifold or to something, but they don't have a dedicated hydraulic line going to it, meaning that it's useless. It's plumbed up, it's ready to go, but the only way to get hydraulics to that function is for the ROV to swim in with a hot stab and plug it into that receptacle, and then through the hydraulics on the ROV, start pumping hydraulic fluid, and now he has introduced hydraulics into an area that was not being used at the time. That's where all of these hot stabs come into play. So they're very integral to the ROV systems. The ROV guy will have it in his hand. The plumbing will go to his hydraulic source, and he'll fly up, plug it in, and start the hydraulic process, thus getting fluid to an area that had no fluid going to it in the first place. That's what the hot stabs do.
You'll see this time and time again that a lot of the control systems have a dual redundant philosophy. So if the control system fails, there's an intervention method to take control over the facility or platform, well, what have you, via the ROV, so they can continue to control, do a controlled shutdown or startup, whatever the case may be.
See, in the older days, what you had on the backside of all of these hydraulic fittings and fittings that go into the valves on the Christmas trees, they were generally, before all this welded steel tube, they were a threaded connection. Another thing that people don't understand is that when a Christmas tree is producing, it's not just sitting there idle. There's a lot of vibration that goes on. You can well imagine 10,000 psi of screaming gas coming up through the well. That wellhead and Christmas tree are vibrating all the time. So what that did over a period of time with all these fittings that were on the Christmas trees or anything, they would literally vibrate loose. And if they vibrated loose, you lost your hydraulic power. So very keen what the industry started doing with those, like the hunting connectors. Now when you see a system, it's generally steel tube through the umbilical, through the Christmas tree, to the function. So you're eliminating all of those threaded connections. You want all that to be welded up, one continuous piece, so that you don't have fittings that could possibly shake loose and start leaking. So intervention panels, very key to the subsea equipment that you put down there. So once again, you got to think through your functionality and what your backup plan is in case something goes wrong. It's more money every time you're adding something, any of these accessories. You go and you buy a vanilla ice cream, it's 50 cents. You want Hershey's on it, it's 75 cents. You want sprinkles on it, it's 80 cents. So same way with this equipment. There's basic equipment and then what you want to do to it to help you further down the line. That's what I'm showing you with all these accessories, things, options that you have to go to. Programmable junction plates. I'll try to go through this as quickly as possible. We're running a little late again. But what you may want to do, this is another option that is very smart, is that here's the junction plate on your Christmas tree or on your UTA. In this case, it's the Christmas tree. So this is where those hydraulic couplers go into the bottom side of those couplers that you saw on the pods and the SCMs. They go into the control module. So hydraulic fluid is sent in there. It's sent out. Generally, it comes down and goes to that tree function. So that's the logic. Into the pod, out of the pod, to the function. What you may want to do is put yourself another plate on the Christmas tree and you plumb up all the functionality identical to the way it is here and run it to the tree. If something happens, you have the ability, because you always in your umbilical try to build yourself spares, meaning that just like those valves that I showed you, the shuttle valves can plug up. It's not very uncommon for complete umbilical functionality to plug up. Well, if you've got 39 miles of umbilical that's this big around, the last thing you're going to do is go pick that up and try to fix it. So build yourself some spares. So what that does, that's all configured and it's all plumbed in to the module. But what you can do is plug all that identical and make it happen. If something goes wrong in the umbilical or the flying lead, you can go out with the vessel and pull this thing. And basically what they're doing is they're looping the valve. They're looping the So they're coming in, they're making a loop, and they're going back out, identical to the control module. If you have a line that is not functioning anymore, you can run out and pull that plate, and you can open it up and reconfigure it, find the spare line that wasn't being used, and replumb it. So what was not being used before, you take that fitting, move it over, and plug it into another fitting, and now you've got functionality back to your valve without doing anything to the flying leads nor the umbilical. You did it at the Christmas tree. Just another piece of insurance for you. Did y'all follow that, what I'm saying? It's spare philosophy that if something happens, you can break the thing apart, and this is the most economical way to fix that. Another way to do it is pull both ends of the flying lead, bring it back to the deck, and you can reconfigure the flying lead the same way, because it generally has functionality that's not being used. It'll have a spare coupling. In some cases it won't, but you can run out there with more couplers, reconfigure the flying leads, and get that source to the right spot, and then rerun the flying lead. But that's a lot of time. And especially if it's steel tube, now you have to cut, and you've got to re-weld on the back of the vessel. So flying lead, it can be done. It's just more time consuming and more work involved. And generally, the thumb is if you ever unplug something and retrieve it back to the surface, you're probably doing more damage to other components than the original problem that you went out there to fix. Anytime you unplug something and you plug it back in, you always have the risk that you damage something other than what you went out to fix. So this is a very cheap way to get you back in business by just adding a little bit of equipment to your Christmas tree. Don't have to do it. It's just an insurance policy.
Stick into the board,
They stick into the bore of the well.
so that's a leak path.
That's a leak path. API flanges, that's an API R36 groove and an API flange. But it is a leak path. But so is everything else, you know. I would buy them just for the knowledge. Otherwise, if you don't have this equipment on there, the only indicator you have is what you're seeing at the host facility. That's the only indication. You can daily go out there and say, I was flowing at 25,000. The next day I'm at 2495. The next day I'm at 2490. You can gradually formulate. But if you have this kind of equipment built into it, you can get a data point on where it's failing at. And that might lead you in the right direction of what you need to do. If it's down in the wellbore, you probably are headed for a workover. You're probably going to have to go out there, either pull the tree or not, depending on what kind of tree you have, pull that production string out of there and find out why it's not producing. Is it in the pipe, or is it just the well is starting to shut in? It's starting to lose its pressure, its velocity, it's dying. Nobody runs forever.
Did you say that sensor is from outside into the board, or is it put into the inside?
This is the external
Yeah.
that you would see your line from your junction plate come into. This is what is actually sticking through into the bore of the Christmas tree.
But the way that's bolted on there, so that API flange is bolted to the outside of the.
Christmas tree. There'll be a block somewhere on that Christmas tree that it will have a bore, and you flange up to that, and it penetrates into the Christmas tree. Sometimes they're in the production, in the block of the tree. Sometimes they'll put these in the what's called the wing. So after it comes out of that production bore, it turns, and you'll have what's called a wing valve. It's a second. You have 2 production valves. Remember the redundancy? 2 valve path leaks. It'll make a 90-degree turn, and generally you'll have a set of valves there, one called the wing valve, and generally the chemical injection valve somewhere in there. You can also mount them in there, so it just depends on where you want to put them. Generally they're bored into the block of the Christmas tree. Jim made mention last week, sand detection is also very important. When I say production, you may want to include those kind of sensors to put sand indicators in there. Because it doesn't take very long for, if the well has been flowing nice for 3 years, and all of a sudden something's going on, and you're starting to see a little bit of sand, a little bit of water creeping into your production, you know that slowly but surely things are changing in your reservoir. And if it is sand, and if it is screaming through your system at 10,000 psi, if you've ever seen sandblasting, it doesn't take long for it to completely deteriorate the ID of the production pipe, the Christmas tree, the jumper, and the flow line. It's all a series. And if you allow that to happen, you will start having detrimental damage done to the equipment. So maybe sensors are what you want to put on the Christmas tree to detect sand. They're generally put in the jumpers, but every once in a while they'll include them in the Christmas tree as well.
Around the wing valves.
I'm more of the wing valve. So I'm running a little late, so I'm going to kind of speed up. So here's what some of the chemical injection systems look like that are put on the host facilities. In this case, we're pumping methanol from this. You can see your input connections from wherever the source of the chemical that's being put on the host facility, whether it be tow tanks or maybe gigantic volumes, and you're pumping through these pumps. In this case, on the upper right hand, look at all these series of pumps. This was a system that we built that went on an FPSO that was controlling multiple wells. Instead of having independent ones for each well, they married a chemical injection system into one skid package. And then that skid then was controlling each well. It also helped in the redundancy that you didn't need as many components, and you also built your spares in there so that if something goes wrong, you maybe can channel and reconfigure the spare into functioning again. Because a lot of these wells, guys, have to have those chemicals 24/7. Some of them don't, some of them do. So this is a very key component for keeping running all the time.
Was that a finished product for you guys?
Yes, this one?
Yes.
Yes, both of them were. This one was kind of unique because the customer, Newfield, decided to marry his chemical injection system and his hydraulic power unit into one skid. So he not only had all of his hydraulic power and electrics in the skid, he also had his chemical injection as well. So why did he do that? He saved in some redundancy on his electrics. You start thinking about the power sources coming in to power these things. He saved a little bit in there, but his ultimate goal was he had a very small space to be put on the host facility. So by having two separate units may have hurt his square acreage, if you will. So he married it into one skid. He also, you saw on some of those hydraulic power units, they were manual valves.
Yeah.
Now, showing my age, if you walk up to most of the control panels now, they're all push button electronics. You hardly see, if it's a new system, you hardly see any of these hand valve movements anymore. It's generally a touch screen.
AF Global was a combination of both. It was manual valves with pneumatic actuators with buttons.
So instead of those hand push things, you walk up to a panel and you're pushing electronically to do functionality. Different kind of pumps. I won't go through this but it's all about if you go cheap or you go expensive. The problem with chemical injection pumps is that you need them 24/7. So you need backups, and you also want to make sure that with these nasty chemicals that you're pumping, that these pumps are set up to handle the kind of fluid that you're trying to push down this line. So redundancy in your types of pumps come into play. Always have a backup, and always start thinking about, should I buy the Pinto or the Cadillac? What am I trying to do here?
That dated you.
That day,
Bring it
Pinto?
up.
Pinto? What's a Pinto? I mean, a horse?
Some of these
A
young
horse?
guys don't even know what a
Pinto
is.
Yeah, Jim is my He's my go-between on where I'm at presently and where I came from. iWalks, we've already kind of been through this. If your umbilical is not plugged into your tree or your manifold or whatever, you're relying on the same, this doesn't change too much from the actual hydraulic power unit that you're installing permanently. Same functionality. The only difference between this gear and the umbilical that's running down temporarily is that they're set up in many different configurations to do many different wells. So Oceaneering has pretty much the key on this. We are starting to looking into a little bit of this. Scott left. We're starting to, I think the eyes are opening a little bit that this could possibly become a new product line for us. Not only selling these units, but maybe renting them. So keep your eyes open to this, because we may be headed in that direction. It's good money. WW welds them up. UI puts the umbilicals on. We build the reels. And not only would we sell these, but we may get into some kind of rental. Now, I didn't say that, but I'm just saying maybe. So this is what your iWalks typically looks like. You've got an HPU, you saw the reel, an overboard shiv, some kind of tugger line, and you're running down either if the riser is running with the system, and in this case they're plugging the iWalks into a BOP stack, and then they're jumping from the BOP stack to the tree via a flying lead to get control of the Christmas tree if you were going to run the BOP stack to possibly pull this Christmas tree. And what's sort of the new idea, and I don't know that this is really taken on, is instead of that big elaborate spread out there with the iWalks, is possibly the ROV doing some of the functionality, especially on if you run that horizontal tree. You may not need an iWalk system on the back of your boat. You may rely on the ROV to do the same functionality that the big elaborate iWalks rental gear would do. So generally when you're running that horizontal tree and you're sitting on the well, you have to open up a couple of valves. We talked about that vacuum. It would happen if those valves were closed and you were trying to set that tree in open water. It may not want to go down because you've got some air underneath it. So you may have to open some valves. So generally what you're trying to do is open valves, and then once it's set, inject chemicals in between the wellhead and the Christmas tree, evacuate all that salt water out of there and put a nice chemical in there to keep it from rusting and whatever. So basically all the ROV then is doing is opening and closing valves and injecting a few chemicals. And there's also one other test. It's called the VX test, which between the wellhead and the Christmas tree is a steel gasket, metal to metal. And he's got a port that he can plug hot stab into. And he can test to make sure that the Christmas tree and the wellhead and that gasket have sealed. And so now you know you have a good seal between the tree and the wellhead. So 3 functions he's doing. So instead of that big elaborate iWalk system being rented and going out on the back of a boat, you just jump the ROV and he does the exact same functionality. These things are taking about an hour and a half, aren't they? Somewhere in there. Sorry about that, but hope the WW guys don't get in trouble for
Take your time, man.
delaying it. Anybody got any questions? Questions? Y'all got it, huh?